Okay, go click that. Let me know once we are live. I think I just saw that um, on the YouTube stream. Yeah, we're live, he says. Okay then. Then I will try to start my presentation then. Okay, so today's topic is an absolute beginner's guide to CI/CD pipelines. But before we start, I want to do two things. The first thing is talk about who I am, and the second thing is give a big shout out to people who are hosting us. You can find that information in the description below the video, and big shout out to MSP CE community just for having me today. So at first, who I am. This is my picture. In the description below, you can find my social networks. Um, so I do a lot of Azure. I do a lot of .NET, Java, Scala, all that kind of stuff. And recently, I started doing a lot of DevOps job. I at least know something about it. And nevertheless, despite of technical stuff, I'm doing community work as well. So I'm leading a local community of software engineers here in Lviv, Ukraine. We are doing kind of meetups each month to talk about stuff we're working on. So today's topic, if we get back to that, is Absolute Beginner's Guide to CI/CD, and I want to give you a brief overview of that, or a complete guide, or whatever. So I want to talk about CI/CD and why you should care about it. So yeah, let's get it. So at first, I want to say that there is one perfect document, I would say a scientific research, which says how to look smart during meetings, and I love it so much. And I even adopted uh, to a new variant of that, how to look smart during presentations. And one point I love here is encourage everyone to take a step back. So uh, let's just take a step back and try to figure out what exact problem we are trying to solve with these CI/CD practices and all that buzzword stuff. So at first, we are as software engineers trying to deliver stuff to production. Nevertheless, sometimes it ends up being a bug, sometimes it ends up being a feature, but we are trying to ship stuff to production, to our end customers to make their life easier. And in the end, when we are done with the coding work, we need to integrate our changes into a working system. So, in other words, we need to make sure our code works with other code that is already in the system, that we don't break anything and the system continues to function smoothly. So basically, that's the term, which says continuous integration is a strategy which ensures that everybody's changes are integrated into a working app. So working app in other words, is production environment, your staging environment, dev environment, whatever it is. Just environment where you can run your app. So, and basically we have a few building blocks to ensure that this CI/CD process is possible. So at first we have version control system. We have CI server, we have build and release automation tools, infrastructure automation tools, and test suite. So basically, VCS is a place where you store your code, and a good example might be a Git or GitHub, Bitbucket. CI server, most of the times it's a real person who takes your build artifacts or whatever and brings that stuff to production environment. But in the end, we're trying to build a great software or at least mediocre software. So we need to have that all that automated. So we are not going to do that manually. So most of the time, CI server is your Azure DevOps machine or Jenkins slave, whatever. And build release automation is something that we need so badly because all your stuff needs to be buildable and easy to release in like one click, one function, one CLI command, and so on. And infrastructure, we are going to talk about that a bit further to go into details deeper. But for now, infrastructure automation, you can think about it as a schema, which says to create an environment, I need to do this. So a subsequential set of steps. And of course, a test suite, which ensures that we didn't broke anything and our system is still up and running. So VCS is a very obvious concept, a place where we can merge, store our code, do pull requests, and whatever, do features. Sometimes it is referred as a trunk, like branches are referred as trunks, but for now, let's keep the simplicity and say that we have only one branch, like master branch or develop branch, and that's it. CI server. So in my understanding, CI server should be a machine which knows which exact set of instructions you need to execute so your system can create a build or something like that, produce an artifact, and tag this artifact to one of your environments. So, and this artifact can be applied to your environment. And infrastructure automation is a complex schema. As I said before, it is a schema which describes what should be done in terms of your infrastructure. What do you expect to have? And of course, you are going to run that schema and you are expecting to have this infrastructure in your environment. Of course, it is highly parameterized and very flexible, extendable, and so on. The next step is build and release automation. So when talking about build and release automation, I expect to have something that we have in .NET nowadays, like .NET build, .NET package, and so on. And that's it. That's just it. We need a quick and programmable way of creating our build, of building our software and creating a build artifact. So this artifact can be pushed to some web server so we can bring that to our users. And we don't need to do any manual steps about it. So build is .NET build, obviously, and release is like Azure DevOps pipeline, which takes your artifacts to production, for instance. And of course, a very crucial part of any CI/CD pipeline, which ensures that we didn't broke stuff and our system is still up. So it's testing. And by testing, I mean various types of tests, which we are going to cover later. But for now, let's just think that we need something that ensures that our system is not broken after the latest changes. And on this slide, I want to say that CI/CD is not a set of rules or something like that, but it is rather a set of practices. And I would say that most of these practices are optional to use. And every company builds its CI/CD process. Any project builds its CI/CD process on their own, and what they have is the result of their work, of their experience, and so on. But for now, let's just go over main concepts of CI/CD that I find very fancy and which gives a lot of value to me personally. What I really appreciate as a person who does software engineering and makes use of all these practices. So at first, I want to talk about iterativity. So as you could have understand before, we're going to trigger a build of our CD pipeline, a run of our CD pipeline, each time we bring something new to our VCS. And this means we're going to run each commit. And if in one commit we have like 10 lines of changes, we still need to verify that those 10 lines of changes didn't broke our system and we're still good to go. So that's one of the most important parts for me. So as far as I go, I can see that this commit broke the build and I need to fix problems with that. So make it green or something. And I can do that right away. And it is very transparent, to be honest, because everybody can see that, hey, your commit breaks the build and say, go fix that. So obviously, this is very important in any CI/CD pipeline, ability to run builds and fix problems right away as you see them in broken tests. Obviously, we don't have many problems with um, like off by one errors or whatever because everything is automated. So personally, I trust machines more in terms of that routine work that you are doing like 100 times a day, like triggering a build. So it is very good to have all that automated, and that is one of the concepts that we have in CI/CD. So the process is transparent, as I said before, so everybody knows what is going on and in which state our system is right now. Obviously, we have easy rollback because once we achieve green build, we are ready to say that this part of the system, this version, it is stable. So if needed, we can just roll back to that version, to that git commit or something like that, and that will be it. That will do the thing. And of course, we can deliver like 5 times a day to production because we exactly know what breaks the build and what doesn't. Of course, it is very powerful and helpful when you have a few environments. So at first, at dev, you can trigger your stuff, build your stuff, and fix errors. Then you push all that to your next environment, which is staging, for instance, where QA engineers test your stuff manually or writing functional test suites to verify that some scenarios are working, and that's it. Nevertheless, you can deliver 5 times a day, 10 times a day, 100 times a day to any of your environments depending on your process. And of course, an important part of perfect CI/CD pipeline is infrastructure automation. And when I'm talking about infrastructure automation, there is a pattern of doing that called infrastructure as code. and the whole sense of it that you once describe your infrastructure and you store it in some kind of repository, so you can pull it and your CI server can populate all that infrastructure for you, and you don't need to do any manual actions. You just need to say like how many virtual machines you want if you have it as a parameter in your infrastructure pipeline, how many instances of event hub you want, and so on. Or just say you want to specify a name of it each time. So it is very crucial to have this infrastructure automated because you have to create your infrastructure many times. And if you have this automated, zero manual actions will be involved, and it is less likely that you'll make any mistakes during that process. Okay, so we're getting to the report section, and I would say that understandable reporting is a part of transparent process. And in other words, I mean, by having understandable reports, we can say that everybody knows what is going on. So, me personally, as a software engineer, I want to have some kind of dashboard to see what is going on in my system. Is somebody working on my service, my part of functionality? Is somebody currently breaking the build by his changes? What is going on? So this is very important in the end. And this is a example of understandable report, or at least part of it. So this says that we have like 6, 7 stages of pipeline, and we can see clearly when this build was executed and on which part it failed, what is going on right now, how much time it takes, and so on and so on. And all that is very important in terms of transparency, because if I can see who broke that, I can go to that person and ask him kindly to fix that build. Or if I'm the person who broke the build, I can see the logs here, and that will help me a lot in fixing the build or fixing the tests and so on. So next, we are going to look at some of implementation examples of building blocks that we've seen before. So as mentioned before, a good example of VCS is GitHub, which was recently acquired by Microsoft, and it is very easy right now to use that in terms of you have free private repos and so on. So I would encourage everyone to take a try, take a look on GitHub and try their GitHub education pack if you're still enrolled as a student, which will obviously help you a lot to learn stuff. It has a lot of subscription to a Pluralsight, Azure courses, and so on. Nevertheless, the second uh, alternative to GitHub is Bitbucket, and of course there are plenty of them out on the internet. You can find that, but that's the most obvious ones. So GitHub and Bitbucket. CI server. There are a lot of CI servers on market, but the most popular ones are Azure DevOps, which was formerly VSTS, Visual Studio Team Services, Jenkins, and TeamCity. TeamCity is made by JetBrains, if I'm not mistaken, and Azure DevOps obviously is made by Microsoft. And I don't know who does Jenkins, but it is a decent product as well. Release automation. So this is a screenshot of Azure DevOps pipeline. And obviously what we can see here is that it says it does some actions in PowerShell before pushing your app to production. It doing some database backups and finally does deploy of your web app. And after all that, it produces you some kind of report, which it says run PowerShell test site compilation, whatever. So the whole point of that is you can specify a set of steps that needs to be executed for your app to make from local machine to production. So, and this is very easy to understand, especially if you are working with a team who cares about naming. The more descriptive names you have here, the more understanding you'll have just by looking at your pipeline. And this is one more example of that. This is how in Jenkins pipelines you do that. So you have this kind of Jenkins syntax. You're accepting some parameters and you're doing some actions. In this case, it just prints that it will deploy something and it tries to some file. And then it echoes the content of this file. So obviously, both approaches are quite similar, except that in Jenkins pipelines you can save it as a file. But recently, I figured out that in Azure DevOps you can do that as well. They added that feature like a few months ago, which is very useful and handy. This is useful because you can save your stuff in your Git repo, for instance, in your servers folder, and keep everything in one place. So let's talk briefly about infrastructure automation. The first thing I want to talk about is ARM templates. So as you see on this slide, it is ARM template and it describes your infrastructure. In this case, it is some storage account, as you see here, which has some kind of name. It has kind of it. It has public IP address, which also has location of it, like West Europe. And it has some parameter as well. So this is the way of describing the infrastructure proposed by Microsoft and by Microsoft Azure. And of course, it is very useful in terms of describing your infrastructure, for sure. And this is one more tool by HashiCorp, if I'm not mistaken. It is Terraform, a tool which allows you to describe how you want to create your infrastructure, which names, tags, resources you want to populate on your infrastructure side. And this is an example of how you populate Amazon S3 bucket, yeah, with some name and tag def. So yeah, next thing I want to talk about is build automation. So in current world, it is very useful to have all those Docker files, and you'll see that all over the projects these days. So you're just describing what you want from your Docker image as your build artifact, and that's just it. And the less tricky way and more obvious way of doing that is running .NET Build. Of course, those who are familiar with .NET, they know that by running .NET build, you're producing some artifact of your build. In our case, it's DLL files or set of DLL files. And this is very useful. This is exactly what I was talking about, that you'll have one exact command to do a build. And in terms of testing, I want to say that there are plenty of testing frameworks on the market. They all support different languages, but let's briefly talk about the most popular of them. So if you're writing .NET code, you should be probably familiar with XUnit or MS Test or any unit. Those are frameworks which are highly used in .NET world. If you're writing Python tests, you should be familiar with PyTest. Obviously, the name is very descriptive. And JUnit if you are writing tests for Java. Of course, testing is a separate topic, kind of separate, but still it is a very important part of any CI/CD pipeline. And I would say that for our CD pipeline or CI pipeline, we need to define the scope and granularity of our tests. So, for instance, we should write some unit tests, meaning we should test how our function inside of our user manager works, user controller. We should define our functional tests, and by functional test, I mean a test which verifies some business scenarios, so that user is able to create an account and sign in, which is very crucial because if that parts of the system breaks, then it is a very big problem for business side, and because people cannot sign in or sign up. And some kind of integration or automated testing is desirable, of course. And all that leads us to one more type of testing, which I find very crucial. And by this style cop icon, I mean code analysis testing. So if you have a team of 10, 20 engineers working on the same project, of course they are different in their code styles, and in some time your code base will be a mess because everybody are just avoiding and forgetting about guidelines, coding guidelines they were given on the beginning of the project. So Style Cop is a tool which enforces that and breaks the build if something is committed which doesn't correspond to your coding guidelines. So obviously this is very useful because of course you can just copy paste and pass all integration functional tests and so on, but in the long run in terms of maintenance this code will be such a mess and you'll spend a lot of time and money maintaining it. But of course tests are not failing if you don't write tests. So I personally don't think it is a good idea not to write any tests because in terms of CI/CD pipeline, it is the only way you can verify that your system is still up and running. So let's talk about continuous delivery. So if we go back to continuous integration, we can remember that continuous integration is a strategy which says that you need to, let's go back to that slide so you can see and read with me. Yeah, so that's it. That's the strategy which says that you need to integrate your changes into a working app. So by having all those test suites and so on, build automation, we can say that our changes are going to be integrated into a working app. And if we go back to CI/CD, CD in this case is continuous delivery. So it says that we can release something at any given moment. So we have at any moment we have something to show. Obviously, it is a concept which is highly related with iterativity and having always green builds. Because if you are doing a build each commit or producing some kind of artifact each commit, you can say that you can take this build from this commit and roll it out to production or whatever in case it is all green and tests are not broken. So that's why those concepts are always going together, and yeah, that's it. So simply saying, this should say continuous deployment, but yeah, this should say continuous delivery. So in terms of pushing your stuff to production, you have some kind of red button that you need to press to push your latest stuff to production, and that's it. In some systems, they even have this continuous deployment practice, which says that every change you make, and if this change is accepted, it immediately is pushed to a production or any other environment which you have in your system. So in this continuous deployment, you don't have any of red buttons, any kind of red buttons. Okay, so I've prepared a quick demo of what real CI/CD pipeline looks like. But before I do that demo, I want to check the command section on YouTube channel. But okay, it is nothing in there, so nothing really interesting. So let's move on to the demo. So, and this demo will be conducted using GitHub Education Pack or MSP subscription, whatever can work well. And mostly it will be about how to build a CI/CD pipeline for your app. And by your app, I mean any app you can imagine. It may be ASP.NET Core app, it may be Java app, Python app, Go app, whatever. So as you see here, I'm in Azure DevOps right now, and it has some repos. I have a repo, and this repo contains some set of files. And this set of files is obviously my ASP.NET Core app, which is not loading for some reason, but nevertheless, yeah, that's it. So a basic ASP.NET Core app, which you would imagine. Uh, Before this presentation, to save up some time, I've created a resource group, app service plan, and web app in my Azure subscription, and I put some stuff on this web app and set up a build and release pipeline. So at first, let me just do this. I will go into my app. This is Visual Studio Code, and what I want to do is change the picture, because change the picture in my app. So on this screen, you may see that I have already some picture Come on, do something. Because I'm expecting this demo to work. So let's change that picture to a specific pic to add, as I said. And let's go over and commit that. Change picture to correct one. Let's commit that and push that. And once it is pushed, I'll go back to my browser and continue and explaining build and release pipelines. So first of all, I just pushed my stuff, and immediately you can see that a new CI build was created. As you see, it is very transparent and understandable for anybody. That is history of my commits. That is number of builds. That is a branch of on which those builds were executed. So I had some success in running these builds because they were all green. But build is not everything, as you might think. So build is only a description of what tasks you need to do to make your artifact be pushed to some registry. In this kind of Azure pipelines YAML, we're describing what we want from our build. What I'm doing is .NET Publish. I'm creating a zip package of my app, and after that, I'm taking this zip package and publishing that into some Azure DevOps registry. After that, I hope my build is completed successfully. And after that, let's go back to releases. I have a new release pipeline, a very descriptive name, to be honest. And I have some history of my releases. As you might think, I was not really successful for a long time, for like 20 minutes in running this, but yesterday, but in the end, it worked well. So as you see, this release was automatically created after my build finished. And let's go into details of that release. This will probably show me, yeah. So this will show me logs of my release. As you see, this release was triggered because I've created a build, and the build was triggered because I made a push to my branch, which Azure DevOps was listening to. So let's have a look at some logs. Yeah. So the process was quite simple. We downloaded our drop. Drop is an artifact name in this case, and successfully deployed our app service to Azure. Let's have a look at how release description looks like. And then we'll go back to our home page to see whether the picture was changed. So as you see, this release pipeline doesn't have much stuff to do. It has only one step, one stage, so to say, where I describe what I want it to do. So I selected my subscription, which is called Azure for Students. I describe what I want to create. I describe what kind of resource I have already created for this build artifacts. And I described where should it look for build artifacts. And that was it. Of course, it is You can access that in YAML right now as well. And have it in your exactly in your service folder as a file or whatever. So yeah, it describes all the steps I'm making to make it possible from like build artifact to production environment. So and if we go back to this app and hit Control F5, we should be able to see some magic. Yeah, it's something. Ta-da! So yeah, exactly that. What was I expecting? And I think that's it for demo. It was intended to show how easy it is to set up pipeline of easy and some sequential steps for your app. And it is not really hard, for sure, even for that simple app. So if we go back to our presentation, we'll see that I've left some homework for you because I think we're running out of time already. I'll send two links into YouTube comments section with description for good CI/CD pipelines. And I would encourage you to have a look on those links and spend like 10 minutes of your time trying to understand that. And if something will be not clear, I'll explain that later in private messages if you wanna. And that's it, folks. If you want to find some information about me, you can find links in the description below. Yeah, just hit me up on Twitter, LinkedIn, GitHub, Facebook. I am always happy to help. And thanks for your time, folks. That's it.